In this short video, I just want to go through with you how to do integrals on your calculator. The AP exam is going to give us integrals that they do not expect us to know how to do. And they will assume that you're going to get that value on your calculator. They will also give us integrals on a calculator section that they know we're going to use our calculator to get, and they're okay with that because that's not what the question's about. So a lot of times on open-ended, really the goal is that you write the integral. That's the main part of the problem. And then finding the answer is really just a matter of going to your calculator. So it's important that you know how to do them correctly on your calculator because it should be a free point in those instances. So there's a couple different ways to do it. I'm going to show you all three ways, and we will talk about kind of the advantages of each way. So the first thing I always do when I'm dealing with any kind of function that I'm doing the integral of is I graph it. So if you go to y equals, I have typed in the function already, 0.2 x cubed minus 3. So if you want to pause this and put that in your calculator so you can follow along, go right ahead and do that. I like to graph it because what we know about integrals is that sometimes they have positive values and sometimes they have negative values, and we also know that cancellation can occur. So if I can see the graph, I can pretty easily see here that depending on my interval, I have potential for cancellation. And so I can kind of keep in my head that that's a possibility, and there's situations where I'm going to want that cancellation, and there's situations where I'm going to want to avoid it. So if I know the cancellation is a possibility, then I know to keep that in my mind. So it's nice to see the graph. Okay, now you can find the integral of this function straight from the graph if you use your calc menu. So if you go to second calc, you will notice that the last option is the integral. Okay, so if you click down, you can either arrow down to it or you can just choose option 7. When you do that, it's going to ask you for your limits of integration. So it says lower limit and upper limit. Let's do from like -1 to, let's see, 1, 2, what do you say? Like -1 to 4, I say. So my lower limit will be -1. I hit enter. It says, okay, well, what's your upper limit? I'm going to say 4 and hit enter. And this is my favorite part. It colors it in. So it colors it in for us and it gives us an answer. So you can see down here, it's showing us 2.25. And again, as the mathematicians that we are, we can clearly see here, oh, I'm sorry, that's -2.25, that there was cancellation. So what this is letting me know is that when I took this positive area and this negative area and combined them, the value I got was -2.25. Now, if I do not want that cancellation, there's a real easy way to get rid of it. Watch this. I'm going to go into y equals, and in front of my function, I'm going to insert and I'm going to add the absolute value function. So I've done second delete to get insert. Notice my cursor's flashing there. It's going to add something. I'm going to go to math. I'm going to go over to number, and I'm going to choose ABS for absolute value. Okay, so, oh crap. So if you have the old syntax on these calculators, what it does is it does ABS and then opens parentheses, and then all you have to do is go put parentheses at the end. Lucky me, and that's only half sarcastic, I don't have this particular emulator has the newer syntax, which is actually lucky. I should not complain. So I'm going to have to type my function in, but that's okay. So I do the absolute value of my function. And then I want you to see what happens to the graph. If I can just... Okay, so now look what happens when I graph it. What have I done? What have I done? Okay, there we go. Now look what happens when I graph it. All it does is it takes all the negative y values and turns them into positive y values. In other words, it takes the part of this graph that was negative and it reflects it up over the x-axis. So if I do that integral again, if I do second calc from, what did we do? -1, I believe, to 4.